Hi, it's Wendy again, and this is part 4 of our series on file input and output in Java. In part 1 of this series, we just did an overview of terminology and talked about the structure of data files. In part 2, we took a really quick look at the API for the file I/O classes. In part 3, we learned how to write code that output data to a data file. And in this part, we're going to learn how to write code to read data in as input from a data file. And in the last part, we'll learn how to use everything you've learned so far to write applications that can do file I/O. So file input has a similar 3-step process, just like you learned with file output. The first step is to connect a character input stream from your data file into your application, and we can actually do this in Java using the scanner class that you're already familiar with. The difference is that in the scanner's constructor, instead of using system.in, you actually pass it a file object, and we'll talk more about that. The second step is to read the data in from the text file. Again, you're already familiar with scanner, so you know how to use methods like next, nextInt, nextDouble, and nextLine. So what we'll do is we'll talk about when you should use each kind of method. And then lastly, you must close the stream. And again, we have a close method available in the scanner class. When you first learned scanner in semester 1, you probably already were told that you need to close the stream. Sometimes we forget to tell you, and you may have never done it. It just depends on who your teacher was. But generally, you should close the stream. And again, we're going to talk about that as well. Now, it's interesting to note that even though we are using the scanner, there are actually classes that you can use that are very similar to the classes we used with file output. For example, when we did file output, we used the file writer, print writer, and buffered writer. There are actually file reader, buffered reader, and print reader classes, but they're a lot more complicated to use. So around version 5 of Java, they decided to add the scanner class, and that made it a little bit easier. It wrapped all of those reader classes together and sort of consolidated the code, and it just made it a lot more user-friendly, or maybe we should say programmer-friendly. Now, before we get into the coding, I do want to review some of the more important concepts of the scanner class. It is important to pay attention to this part because in order to understand how to properly read the data in from the file, you really need to have a clearer understanding of how the scanner works. Your past experience with scanner, you're probably going to remember that you have some trouble sometimes when you mix the next line method in with some of the other next methods. So in order to understand that better, we're going to review some of these concepts. Now, the scanner reads what are called tokens. So imagine we had a string. Mary had a little lamb. Let's say the user input that string and then pressed enter at the end. So you can see I've added a new line character because when you press enter, that actually does put a new line character. Imagine this is the input buffer. We talked about the output buffer in the previous video when we learned about file output. So the input buffer is similar. When you use a scanner, let's say for keyboard input, when the user types their data, it sits in the input buffer until a next method, nextInt, nextDouble, nextLine, whatever, executes and takes that data out of the buffer. The same thing is going to happen when you use a scanner with a data file. So imagine this string and the new line came from somewhere, keyboard, file, doesn't really matter, and it's sitting in the input buffer. What the scanner does is it tokenizes this string based on a delimiter. We've used the word delimiter before. We talked about delimiters. They're basically separators. So for most of the next methods, the default delimiter is white space. A white space character is things like a space character, a tab character, and a new line character is actually a white space. So you can see here in this example, we've actually got several delimiters in this string. So each one of these spaces and the new line is, by scanner's rules, it is a delimiter, or these are delimiters. So that means this particular string has several tokens. Each token is around a delimiter. So for example, Mary is a token, had is a token, a is a token, little is a token, and lamb, including the period at the end, is a token as well. So this particular string, wherever it happens to be, has 5 tokens. 1, 2, 3, 4, 5. So if I was to invoke the scanner's next method on this string, it would return the value Mary because that's the first token. If I was to then execute the next method again, that would return had. That's the next token. And of course, if I execute next again, it's going to return A. That's the third token. And then again, I would get little. That's the second last token. And then lamb with the period on the end is the last token. So this is how the scanner works. It reads in tokens based on its default delimiter. If you read the notes, I actually show you in the notes how to change the delimiter. It's probably not going to be necessary unless you're playing around with some funky files, but it is interesting to note that you can change the delimiter if you want to. Now in this example, I'm only working with the next method, which always returns a string. It's kind of interesting also to look at how this works when you're working with primitive types like ints and doubles. So in this example, somewhere in my memory buffer or my input buffer, I have a floating point number, 123.4, and then there's a single delimiter space, and then 10, and then there's a delimiter on the end. That's the new line character. Again, the space and the new line are white space characters, which is the default delimiter. So that means there's two tokens in this example. 123.4 is the first token, and 10 is the second token. So if I chose to take a scanner and invoke next double, that would return the first token, which is 123.4, and then if I invoke next int, it'll read the second token and return that, which is 10. What these methods actually do is they read in the data as a string and then they try to parse it. So it's actually reading 123.4 as a string and then it's parsing it into a double. And then next int is reading the 1 and the 0 as a string and then parsing that into an integer, or an int if you want to be correct. Now what's interesting is if I did next int first, that would throw an input mismatch exception because it'll read the 1, the 2, the 3, and the point, and then the 4. And when it tries to parse that into an int, it says, oh, I can't do that because there's a decimal point in there. So it'll throw an input mismatch exception. So you want to be really careful when you're using a scanner for a file. You want to make sure if you are using methods like next double and next int, that your data file, we use the word integrity, that your data file has integrity. In other words, that the data in your data file is correct and accurate. You can't always guarantee that. So one of the other things we'll talk about is how to go about making sure that your program doesn't crash if your data file has unknown integrity or bad integrity. Now, as you know, the next line method is different. The next line only uses the new line as its delimiter. So if I took the Mary had a little lamb in my input buffer with the new line at the end, the next line method only sees one delimiter. Next line will ignore white space. So it sees the one delimiter on the end. That means that it sees only one token, and that's the Mary had a little lamb with the period on the end. So if I was to invoke the next line method on this, I would get Mary had a little lamb with the period. So again, the next line method, it doesn't really care about spaces or tabs. It only pays attention to the actual new line character as the delimiter. As soon as it sees a new line, it says, oh, I'm done. This is my token. So the scanner class itself actually has 3 constructors, and of course you're already familiar with one of those. That's the one that takes system.in. System.in, as you might recall, is the keyboard. It's your system's default input device. So when you invoke this constructor, what you're basically doing is you're saying, I want the source of the input for this scanner to be the keyboard. In other words, the system's default input device. There is another scanner constructor that takes a string. I talk about that in the notes in case you're interested. You actually might find it useful when working with data files, but I'm not going to use it in this demonstration. I'm going to use the third constructor, which is the one that takes a file object. So here you can see I've created a file object, and then I use that file object to construct a scanner. This, by the way, will throw, I do believe it's a file not found exception if the file object refers to a file that doesn't exist. So it might be worth it to use the exists method on your file. You'll still have to handle that exception though, for reasons we're not going to get into today, but we will in another lesson next week. So when you use the file object on your scanner, what you're saying is that I want the source of my input to be the data in this file instead of the keyboard or something else. So you're just switching the source of input. You're saying for this scanner, the source of input is going to be this data file. Now it's important to note that if you were to pass the path and or just the file name into your scanner constructor like this, for example, if I want to connect my scanner to a data file example.txt, even if it's in a directory, if you put path information in here, it doesn't matter. The problem with this is a string value. It's not a file object. So what scanner thinks you're trying to do is use the other constructor, which takes a string, and it thinks that you're actually using this string as the source of input. So if you were to invoke, say, the next method, it will just return the actual letters example.txt. So you want to be really careful in your programs when you're using a scanner to get input from a file. You can't do it this way. You have to use a file object. I see this mistake all the time when people try this because, you're just having a bad day, you forget or whatever, and then they don't understand why there's no data being read. That's why, because you might have forgotten the file object. So keep that in mind. You can't do it with a string. You have to use a file object. Now I want to show you some do's and don'ts when it comes to working with a scanner. Again, I know you learned about this in semester 1, but I just want to remind you because some of these things are actually a bigger deal. I mean, they're a big deal anyway, but they might be a bigger deal when you're working with files. So let's say, for example, you construct a scanner object using a file, and then you want to pass that scanner object into a method. That's okay. That's actually a good idea. Why would you do that? You might have several different methods that all need to use a scanner. Scanners are very resource heavy, so if you just create a new scanner for each method, that's okay, but then you're using a lot more memory than you need to. What you might want to do is create one scanner in your main and then pass that scanner into every method that needs it. That's okay too. Another thing you want to make sure you do, you want to make sure you always close your scanner. Just like you learned how to close the print writer and all the output streams, you should do the same thing with the scanner. And in fact, it's also another good idea when you finish with your scanner, not only to close it, but it's also a good idea to assign it a null. What that does is it takes the actual scanner object out of memory and makes it available for Java's garbage collection mechanism. I don't know if you got to talk about garbage collection at all in semester 1. There's not a lot of opportunity to do that, but Java has this built-in garbage collector. It basically looks for unreferenced objects and then cleans them out of memory for you. So if you've got an object like the scanner, even though you've closed the scanner, the object still exists in memory. So if you say, well, I'm done with it, I can free up that memory now and use it for something else, then just assign your variable a null. And then that makes that, it's sort of like taking the trash and putting it out at the curb and waiting for the garbage truck to come. That's basically what you're doing. In a lot of languages like C or C++, for example, you actually have to write code to do this manually, and it's a tedious part of programming. This is something that made Java Java, because they actually added this automatic garbage collection so that programmers didn't have to write code to free up memory and get rid of unreferenced objects. So this is kind of a nice feature of Java, but if you do go on to learn a language like C++, keep in mind you will have to add extra code to clean those objects out of memory. So it'll definitely make you appreciate Java even more than you might already appreciate it now. Now here's something you should not do with a scanner, whether you're working with a file or with system.in. Don't create a scanner inside a loop. Even if you say, well, I'm going to close the scanner and then assign it a null when I'm done, loops execute fairly quickly, so even if you are constructing the scanner and then destroying it right away when you're done, you're rapidly creating scanner objects in memory. If your loop is going to execute 10 or even 50 or 100 times, you're going to fill up memory really fast with scanner objects before the garbage collector has time to come and clean them up. The garbage collector doesn't necessarily trigger right away. It kind of comes when it feels like it. So I'm sort of giving it a human characteristic, but it's pretty close. It doesn't necessarily execute a specific time. You generally can't guarantee when the garbage collector will come. So that's something you definitely do not want to do. Do not create a scanner inside a loop. Create the scanner before the loop, and then you can destroy it after the loop. Another thing you want to be careful that you don't do with scanners. So if you create a scanner to a file and then read some data, don't create another scanner to the same file to read the next piece of data. Every time you create a scanner and connect it to a file, it's going to start at the beginning of the file. So, and if you're saying, yeah, but I read through my file and now I want to go back to the beginning, that's true. The only way to do that is with a scanner. Then you reinstantiate the same scanner. So if you want to do that, instead of making a second brand new scanner, just say in one equals new scanner. That's totally okay. Obviously, you wouldn't put the scanner in front if you do that. But I see this a lot with people when they do system.in as the source of input. They create a new scanner for each input. Don't do that. Scanners are very resource heavy. I keep saying it, but it's true. So try and use as few scanners as possible. There is a situation where you might create multiple scanners, for example, if you have two different files. So if I want to read in data from the inventory file and at the same time in the same program, I also want to read in data from a customer file, then fine, you would have to have two scanners for those. When we're working with keyboard input, the only other time you might create two scanners, and this is actually, I do this all the time. If I'm doing a lot of user input from the keyboard and I'm using a lot of methods like next, next int, next double, but then I'm also using next line, then you know there's problems with that, right? You've experienced these before. I'll create one scanner for next line method calls, and then I'll create a second scanner for everything else. So that's one way to kind of get around that problem. But other than that, in this kind of situation, you would definitely need a scanner for each file you want to work with. Then you want to be careful of how many scanners that you actually create in a program. Okay, so let's get coding with scanner. Let's learn how to do some file input. So you might recall in one of the more recent videos on file output, we did a little exercise where you had to create a file description for the episodes of your favorite TV show. So here's a reminder of my solution to that. And another part of that exercise was that you had to come up with 3 examples of records that go in that data file. So what we're going to do is we're going to create that data file by hand. This is kind of a handy tool to have. You can do this in NetBeans or wherever you want. You can use any editor you like, but it is easier to do it in NetBeans. So if you want to just have a data file that you can test on stuff or just for practice, you can actually create a data file on the fly. You don't have to write an application to write the data file if you just want it for testing. So what we're going to do for our first demo is I'm going to show you how to create a data file with some data in it so that you can use it to practice reading input. So here I am in NetBeans. This is the same project I was using in the file output videos, so you can do the same thing or you can start brand new, whatever you like. You'll recall we talked about how in the Files tab over here is where you can see the physical files that make up your project. We did our first example right in the project's root, and then we created a subdirectory data, and that's the inventory txt. That was from one of the other demos that we did, so hopefully you have that handy. We're going to do that actually for our second demo. We'll use the inventory file. But for now, I want to create the episodes.txt because we didn't write a program to create it. It was just a different exercise. So to add a plain text file to your project, what you're going to do, again, make sure you're in the Files tab. If you do this on the Projects tab, it's not going to end up where you think it's going to end up. So make sure you're on the Files tab. Again, if you don't see Files, go to Window, and there it is, select files. And if it doesn't show here, it might be somewhere else on your screen. These tabs are all dockable. Just grab the tab with your mouse and drag it where you want it to go. So right click on your data subdirectory and select new, and you probably won't see empty file here. That's fine. I see it because I did this demo by myself before I recorded it. So you won't see empty file. If you do, great, that's fine. But if you don't, it's okay. Just go to other. And then in the categories list, scroll all the way down to other. And then in the file types list, scroll all the way down to empty file. And then click on next. And then you can type in a name for the file. So I do believe it was called episodes.txt. And you can double check and make sure you're in the right project, make sure you're in the right folder. You can see exactly where your file is going to go. Make sure when you're adding an empty file, you do have to add a file extension. A lot of times in NetBeans, when you add a specific kind of file, like a CSS or an HTML, it adds the extension for you. With this one, it doesn't know what kind of file you want, so you actually do have to put the extension on there. And then you click finish. And you now have this empty episodes.txt. And then you can just type in your episode data here. So if you have that example, even if you didn't type it in that same form, that's fine. You know, you can just type it in by hand. So mine was, I'm looking at it on another screen here, 818. And then my delimiter, that was my episode ID. And then my next field, and again, you might want to check your file description. If you didn't already put this in the format, it would be saved to your file. My next field was the number episode, like overall. And then there was the title, so a delimiter, and then the title of the episode. And then I had a delimiter, and then I had the date. 03. I'm not going to get into date programming and stuff. I was thinking about it, but I think it's a little off topic. So, and then I had the writers. This one's kind of interesting. Can't spell this guy's name. Because I had several writers per episode in some cases. So some of my episodes had multiple writers. So I just separated them with a comma. And I did that on purpose because I want to show you something today that's kind of cool. And then I had the director there. And then you'll see here I'm using the pipe as my field delimiter. And for my record delimiter, I use the new line. So all you do is press enter. And then you add your next field or add your next record. So add your 3 records, or you can add more than 3, but you should have at least 3 for what we're going to do. Go ahead and pause the video, add at least 3 records in that same kind of format, and then come back and I'll have mine done and I'll show you what we're going to do next. Okay, so I've got my 3 records. I'm just going to maximize this a little bit. What I want you to do, I want you to go back and double check. Make sure you've got all your delimiters where they're supposed to be. If you make any mistakes with your delimiters, you're going to have errors in the code that reads back the record data. So you want to make sure you've got your delimiters. The other thing you want to make sure of is make sure, so I have 3 records, so I see my line numbers 1, 2, 3. Make sure you have a blank one at the end. So make sure there's a blank line. And that should make sense because if you did write a program to create this file, you would write all of the data and then add a new line to the end. And then you would write all the data and add a new line to the end. And then you would write all the data and then add a new line to the end. So that way the next record you would add starts right here. On my screen, it's line 4. So make sure you have 1. Don't put 2 because now it's going to look like you have an empty record in between. So you don't want to do that. So make sure you only have 1 extra line there. So if you've got 5 records, then you should see 6 line numbers. So make sure. This is why I like using NetBeans to create my data file and not some other program. So I think in Notepad++, it has the line numbers, but I think the line numbers show up whether you've got text on the line or not. Whereas in NetBeans, they kind of stop at the lines you've actually added, so it's a little more obvious. Notepad, the regular Notepad, has nothing, so you can't really tell. So make sure you got 1 blank line there, and then save it, and you're all set and ready to go. Now you can leave this open if you want. It might help if you want to match up your output with the actual data. It doesn't really matter, but we're going to go back to our program now. You can see this was the code that we wrote before. So if you've got code in here from the previous videos, just comment it out or paste it somewhere else. It's up to you. And so what we're going to do is we're going to write just a really basic piece of code that reads in a record and then prints it on the screen. Once we get that working, then I'll show you how to extract out the individual fields and do stuff with them. So the first thing I want to do is I want to create a file object. Again, you cannot use a scanner with a string file path. It'll just think the actual string is your input. What you need to do is have a file, so new file, and it was in data episodes.txt, and you know by now that that has to be spelled correctly, uppercase, lowercase. And all this stuff is going to have to be imported. I want to make sure that my file exists. So if file exists, like that, you don't need a double equals true. That's redundant. Read chapter 3.6. So if the file exists, then I want to create a scanner. Now you're going to notice, I'm going to call it file in, that once you type in scanner and put the file in the constructor, of course I have to input, that's not the error I wanted you to see. There we go. Then you'll see that it throws a file not found exception. Now, you'll notice that when you're working with files, we've written code before that might throw an exception, right? But this is the first time we've written code where it says, yeah, I might throw an exception. You need to actually do something about it. So don't panic. I know that's a little odd, but we will learn. There is a lesson coming up on exception handling or advanced exception handling, and we'll talk about that then. For now, what this means is we're going to have to put the rest of our code inside a try catch, or you can use the try with resources if you want. I'm just going to do a try catch for now. And for now, just in case there's any errors, we want to actually see the stack trace, so just print a stack trace. When we do that lesson on advanced exception handling, we'll talk about some of the other stuff you can do. Plus, this is a console application. I want to get back into GUI applications soon, so I'm not going to bother too much with the exception handling until we get back into GUI stuff. Again, I always do this right away. As soon as I open my scanner, I make sure I write the code to close the scanner stream, and then I write the code to just assign it a null. Because if you don't do it right away, you're probably going to forget, because you get kind of hung up on all the meaty tasks in between, and you tend to forget the little things. So you might want to do the same thing and stick that in right away. So the next thing is I want to go to that file object, and I want to use these next methods to read in my data. So whenever you work with reading data from a file, you basically want to say read in records until I run out of records to read. There has to be a limit, right? Clearly, when you're processing a file in this way, this is going to be repetitive code. Read a record, process it, and then go back, read the next record, process it, read the next record, process it. So obviously you need some kind of loop, and we don't know exactly how many records are in the file in general, so we can't necessarily use a for loop. If you do want to explore random access files, you'll notice that with those you can, because you just ask it how many records it has and it'll tell you. But with sequential files, we don't know. There's no way to tell how many records are in the file. So we basically want to find a way to say, while I have records to read, please read them and then do stuff with them. You can do that really easily with a scanner. One of the things that you have in a scanner, besides a bunch of methods like next, next line, next int, there's also a bunch of has next methods. For example, has next will return true if there's another string token to read. Has next double will return true if there's a double token upcoming that it can read. For example, if I had in my input buffer ABC space 123 and then 45.6, if that was my input buffer, when I open, or you can say open the file, or when I connect to the file with a scanner and I say has next, that'll return true because there's a string token. Actually, it'll return true on any of these because they can all be read in as strings. And then if I invoke the next method, it then moves to the next token. And now if I say has integer, right, or sorry, has next integer, then it'll say yes, the next token can be read as an integer. So it'll return true. And then if you do next int, it'll give you that integer token, and then it'll move to the next token. And if I say has next double, it will return true because the next token available to read can be parsed into a double. If I said has next int, it'll return false because the next token that's available cannot be parsed into an int. So you got to be really careful. So you can say has next double. Yes, if you then invoke next double, it'll read in that value and return it. And then you're at the end of your input buffer, maybe there's a space or nothing or a new line in there, it doesn't matter. If you then say has next or has next int or has next double or whatever, it'll say false because there is no token to read. So what we can do is, since we're reading one line at a time, all our records are delimited with the new line character, we can use the has next line method. So what we can do is file in.has next line. And what that'll do is, if there is a token to read that ends in a new line character, it will return true. So if you have 3 records in your file, then this will return true until it reads the last record, and then it's sitting at the end of your file, so then has next line will return false. Oh, that's perfect. That's exactly what we want. So what we're going to do, again, just really basic to start off with, I'm just going to print the next token. So I'm just going to say print file in dot next line, just like that. So it's not going to be something you'd normally do. I want to work in small steps, baby steps. So once you have this code here, so again, we're connecting to the file with a scanner, and then while we have records to read, let's read a record and print it. So when we connect to our file the first time, this will return true because we have 3 records. So it'll then read and print the first record. Then it'll iterate back up to the top and it says has next line. Yes, there is another record upcoming, so we will then read and print the second record. And then we'll loop back up to the top and it'll say has next line. And it'll say, yes, that's true. We do have another record coming up. So we will read that last and third record and print it. And then we're sitting at the end of the file. So then when we come back up to repeat our loop, it says has next line. And the answer is going to be no. False. We don't have another line. So then we exit, we close the stream, and then get rid of it. And hopefully we'll see all 3 of our records. Again, it's not going to be pretty, but it's just a demo. There we go. So I'm just going to stretch this up a little bit. So we can see, again, I told you it's not pretty, but we'll make it pretty in a minute. So you'll see there's each of my records. So I'm able to read in each one of my 3 records, or if you have more records, you'll see them all. So I'm able to read in each one of my records and then print them out on the console. So that's fine and dandy, but it's not something I would normally do. I wouldn't just print the raw data from the file like that. That's kind of silly. So let's say, for example, you decided that you would like to print every single record in this kind of format. So for every record you have, you're going to put a little episode ID with the episode ID, an episode number with the number, the episode title, the original air date, the list of writers, and the director. If you want to choose to write yours in a different format, that's fine. You might even have different fields. That's okay. But let's say that's how I've decided. I want every record to show up. And then in between each little block of output, I'm just going to have a blank line so it's easy to tell one record from the next. So to do that, that requires that I actually, instead of just printing the raw data from the file, I'm going to have to parse out each individual field because I want to have a nice formatted string with all of this information formatted in that way. This is actually really easy to do. In the string class, and I know you learned about the string class in semester 1, but you may not have learned about this particular method. It's called the split method. I'm just going to write this here because I don't have a whiteboard, but there's a method called split in the string class. Let me actually just make a string called s equals hi, doesn't matter what's in the string, and s dot split. So there you'll see there's a method called split. There's a couple versions, but we're only going to use this one. What this does is you pass it a regex, a regular expression. It doesn't have to be a complicated regular expression for what we're doing, so don't panic if you chose not to learn regex this semester. That's fine. I'll show you some simple things, and there's some simple examples in my notes as well. So what you do is you pass it a regex, and notice it returns a string array. So what this method will do is if you pass it a record, and then you tell it to split that record at the pipe symbol, it will then return a string array where every element is one field value, one token in your string. Remember, we're working with tokens. So if this is an example of one of my records, 818 is a token, 114 is a token, Artful Detective is a token, the date is a token, these two writers are a token and the director is a token. So these are all the individual tokens. So what the split method will do, if I pass it the record as a string and tell it to use a pipe symbol as the delimiter, then it'll split up my string into the individual tokens between the pipe symbols. Cool. So let's try that. So first we need to do that next line, but we're going to store the next line value, return value, in a variable. So file in dot next line, just like that. We don't want to be calling next line repeatedly because it'll just keep getting the next line, not the same line. So you only want to call it once and put it in a variable. That's a really good example of something that I keep repeating over and over. Call a method once to get the exact same value. In this case, you won't get the exact same value. So you still need to call it once. So I'm going to call next line once and store the result in a string variable called record. And then I'm going to create a string array. I just call it fields because that's what it is. So I create a string array called fields and I assign it the results of record.split. Now, when you do a regex for a pipe symbol, you can't just go and say pipe symbol because in regex, that's actually the OR operator. In regex, you have to escape it. But if you escape it, in regex, the escape character is the backslash. Java thinks you're writing a Java escape sequence. So now you have to Java escape your backslash. So it's going to look like that. So that's the pipe symbol. If you were doing just like a comma, you don't need to escape it. You can just put, whoops, you can just put comma. But because I'm using a symbol that's part of regex syntax, I have to escape it. And because I'm using the escape character, I have to Java escape it. And that's what I end up with. So what that'll do is it'll take out each token around the pipe symbols and put each one in fields. So that means that, and I'll have to look up my file description here, my element 0 is going to be the episode ID. My element 1 is going to be the episode number. My element 2 will be a title. My element 3 will be the date. My element 4 will be the writers. And my element 5 will be the director. So we got to keep that in mind. It's helpful to have your file description handy when you're writing this piece of code, but I can probably do it. I've also got it written here on the other screen, so that's going to help a little bit. So what I'm going to do is do a nice formatted, that's my shortcut for printf. I did that myself. There is one in there already, but I don't ever remember what it is. I'm going to have episode ID. Now, you're tempted to go %d because episode ID and episode number are integers. But remember what we were saying in the previous set of videos. When you output this data to your file, I know we typed it by hand, but it's still stored the same way. When you output your data to a file, a sequential file, or type the sequential file by hand, that data is all stored as a string. So I'm going to read it all back as a string. Later in this video, I'll show you how to read the integer data back as integers and the double data as doubles and all that. Right now, baby steps. So we're just going to work with string data. So episode ID %s. I'm not making columns, so you don't need width specifiers unless you're making columns. We'll do that later. And then I'm going to do a new line. And then on the next line, I'm going to run out of space. So I'm going to do episode title, and that's going to go on a line by itself. I'm trying to remember what I had written on my PowerPoint. And then I had air date followed by the actual air date, and that was on a line by itself. And then I had the writer. Some of my episodes have more than one, so I'll put a little S there. That's generally what we do. And that was on its own line. And then we had director. And then I think that was the end. And then a new line at the end and an extra new line. Notice when I do printf or string.format, I use %n. But if you do \n, that's okay too. Most students like to use \n because then they don't have to remember when to use %n and when to use \n. %n only works in printf or string.format, whereas \n works anywhere. And so now I'm going to fill in, this is really easy, fields, they're all in order. I did that on purpose. So field 0, that was my episode ID. And then episode number is fields 1. Again, these are all strings. I used all string format specifiers. And then episode title was fields 2. Air date was fields 3. And writers was fields 4. We're going to have fun with that in a little bit. And then the director was fields 5. And everything looks okay. So it's a bit long. Don't worry, it's a bit long, but you know, if you've done format specifiers before, it's very simple because everything's a string. And so now I can run this, and there we go. Let's see. There. I'm going to make this a bit bigger. I'll come back to the code in a second. So there we go. So there's my first record. There's my second record. And there's my third record. So all of my records are output, all nicely formatted. So that's fine, but now you'll notice that when I print my writers I think in all of my records, but if I did all the episodes, it wouldn't be all of my records. But in my version, all of my records have more than one writer. Some of them will only have one, and some of them will have more than one. I think one of mine actually has 4 writers. And so I want to be able to make this nicer. Let's say, for example, I want to print my output this way. So I want to do columns. So I want to have a column for IDs, a column for episode numbers, a column for the titles, a column for the dates, a column for, so I'm moving these around, a column for the directors. That's actually my last field. And then I'm going to put the writers where I'm going to have a writer and then the next writer. And that means there's going to be some blank lines between some of the records. That's okay. I don't care. That's fine. But I'm going to put all the writers in a column instead of stretching them across with a comma in between. I just thought it'd be kind of a neat exercise. So this one's a little more complicated. Whenever you're printing data in columns, because things, they have to line up, numbers are always right justified, strings are usually left justified, depending on what's in them, and you want your headings to line up nicely. When you do something like this, that means you need to make one of those little printf or format graphs like you learned how to do in semester 1. So I did one. So what I did was I imagined a row of what my output would look like. And so my first bit of output, that's going to be the episode ID. Some of my episodes, because the series I chose they're just about to make season 14, I think. So that means some of the episode IDs are going to have 4 digits. So I did 4 digits for the episode ID, followed by a space. And so that would be again, I'm working only with strings right now. So that would be a %4s. That's my format specifier. And then you could do 5s if you wanted to, and then not have the space on the next one. But I like to have a space between my format specifiers. I find it easier to read. So I do them exactly, and then just add the actual space. So %4s, and then I'll put a space there when I actually code it. And then my next one is going to be 3 digits. So I do 3 X's followed by a space. And then my next column is going to be the title. So let's say the maximum size for a title, this would be defined somewhere. Right now I'm just making it up, would be 35 characters. So then I would have, I didn't have room for all of the X's, all of this placeholders. So I did a little ... So that's going to be 35 characters. So again, the characters, when I print the title, by default, everything in printf or string.format is right justified. I want this column to be left justified. So I put the minus sign in there. And then my next column is the date. So the date always takes up 8 characters. So I'm just going to do 8 character date, %8s. I don't have to worry about right or left justified because it's going to fit exactly anyway. And then a space after that column. And then the director name. So I think I chose 25. Yeah, 25 characters for the director name. And then 25 characters for the first writer's name. And then to get to the second row, because if there's more writers, then that means I'm going to have a second row for the next writer, a third row for the third writer, etc. So then what I do is I think, okay, if this is going to be if you're doing printf, then this would be printf. If you're doing it in a GUI, then you would use string.format, or if you're saving it as string.format, whatever works. So that would be my format string so far. And then what I would do for if there was more than one writer, then I would add for each extra writer. Oh, I just used a for each. For each extra writer, then I would add another row And all you do is you know that the second and subsequent writers are going to go right there, right? Formatted in the 25 column space. So you just want to sort of, there's no way to tell it like go here and start printing here. And what you could do, you just count up all of these spaces. If you add all these numbers up and then add all the spaces, it comes up to 80. So you could just print 80 spaces, like press the spacebar 80 times, but that kind of sucks. So here's a little trick in case you ever have to do this. I put in a format specifier. Oh, there should be an S in there. I'll make sure I code it properly. That should be 80S. It doesn't matter if you right or left justify, because I'll show you why. So you put in a %80S, and then that format specifier gets a space. So you're basically just formatting one single space in 80 columns. Again, it doesn't matter if you're right or left justify. And then that means when you put in the writer in -25S, it's going to go right there. So let's try it out. Now there's a few different ways you could do this. I tried a couple of different things and I just ended up going with what would be the easiest. I tried, for example, using that format specifier and then cutting off the first writer and then doing a loop, like iterate through all the writers, but it was actually a pain in the butt. You can try it if you want, but it wasn't easy. So what I'm going to do, if you want to comment this out or delete it, it's up to you. So what I'm going to do, I'm going to do this in a string with string.format. And the reason why is because you're typically going to do this in a GUI, so you're not going to be using printf. So I want you just to remember printf and string.format, they do the exact same thing. The difference is that printf sends the string to the monitor, whereas string.format returns the string to you. But some people still have a hard time between the two. So I'm actually going to make an output variable and I'm going to use string.format, because if you're doing this in a GUI, this is how you would have to do it. So what I want to do is I'm going to use the format specifier I designed, right? So this is why I always tell you to actually draw this out on a piece of paper. And I'm going to use, I just pasted it from the PowerPoint. So there's my format specifier. Now the other thing I'm going to have to do, remember that my writers, if you look at an example of my record again, let me just go grab it. There we go. If you look at an example of my record here, you'll notice that my writers, I delimited the writer field with a comma. So what I'm going to want to do is I'm going to want to get a writers array and just use fields, I believe it was fields 4 dot split, and just say split with the comma. So what that'll do is it will take out the first value and put it in the first element and then look for the comma and then take the value after that comma and then put that in the next element. And if I had another one, comma something else, then it would grab the next one. It basically does the same thing as the split with the pipe symbol, only here I'm splitting this particular element by the comma and storing it in a writer's array. So then when I do my values, so my first one is still going to be element 0. My second format specifier is still element 1. My third format specifier, that was the episode title, that's element 2. My third one was element 3. Now my next %25, that's the director, which for mine is fields 5. And then the writers, which is now my last column, is going to be writers element 0. So I go ahead and print the first writer. Then what I'm going to do is I'm going to use a for loop. I'd love to be able to use a for each loop, but unfortunately I can't because I printed the first writer already. And I want to start with the second one. I did, like I said before, I tried this exercise where I just took out this last format specifier and then took this piece out. And then I did a for each loop that started with the first writer, but then you have to make sure there's a new line on the end, and it ended up with an extra blank line in between. It was not easy. It had a lot of extra code I didn't need. So it's actually easier just to use a counted for loop. So I'm going to start at 1 instead of 0 like we're used to, and continue as, I need a variable, Wendy. There we go. Start at 1 like we're used to, and then continue as long as I is less than writers.length. That part stays the same, I++. And what I'm going to do is now if you learned how to do string concatenation like this properly with String Builder, you should do that. String Builder is more efficient in this kind of situation. I just didn't think of it at the time, and not all students learn String Builder, and I don't want to take time to teach you String Builder. So if you learned how to do this properly with String Builder, then by all means, yes, please do that. But I'm going to do it the bad programmer way and just concatenate plus equals. If you don't know String Builder and you're thinking, oh, if it's more efficient, I want to learn how to do that too, then you should. It's in your textbook. Just go to the index and look up String Builder. So my, format specifier was %80s. I forgot the S in the PowerPoint. And then minus 25s. Making sure I got all my percent signs in there. Oh, and I need a new line at the end of that. There we go. And then for the second argument, that's what's going to go inside the %-2s. That's the next writer. So writers I. So this will add, for each writer, it will add a whole bunch of spaces, and then it'll line up the writer's name with the writer's name above, hopefully. And that ends in a new line, so we're good to go. So all we have left to do now is, that's an output string. I do actually need to print it. Now you want to be careful, because if you use print line, it's going to add an extra new line. We already have a new line, either here or here on the end. And if you use print line, it's going to add an extra blank line. And we did that in the previous exercise because it was easier to read. But when you're printing rows on the screen, you generally don't want the extra line. So I'm going to use print and just print output. So let's see how that looks. I'm going to run it. And there it is. So, oh, I didn't do any column headings, but that's not hard to do. So there's my column with my episode ID. There's the episode number. There's the title, the date, the director. And look, there's the writers for the first one. There's the writers for the second one. And there's 4 writers for the 200th episode for my last one. There you go. Now, that was a lot of extra stuff that really didn't have a lot to do with file input, but I have been promising for quite a while now to make a video that just reminded you about formatting with string.format or printf, so that was kind of my way of shoving that in there. So that's a neat example. It shows you the basics of file input. One thing we still want to talk about is this is all fine when I'm just working with string data, but what happens if I'm working with numeric data and I want to start reading integers and doubles and that kind of stuff? So I'm going to do a different example. Remember in one of the previous videos, you created the inventory data file. We had the really basic product ID and then the quantity and then the item price. So let's pretend this inventory is the inventory we sold for a particular day. And what we want to do is calculate the total amount of money made on each item. So I want to be able to read in the data and display an item ID and its total amount, which is the quantity times the price. So that means I'm going to have to read in the 25, for example, the quantity as an int, and I'm going to have to read in the price as a double. So let's see how we do that. If you want to keep this code, you can. I'm going to just do this. I'm going to chop it out here. Okay, so here I am with my main method empty now, and we're now going to do pretty much the same kind of thing or similar thing doing with the inventory text file. So what I want you to try as an exercise, I want you to do a similar piece of code. So you're going to need a file object that's to the inventory.txt file that you created in the previous part of the lesson. And then you're going to, if the file exists, then you're going to create a scanner to the inventory file, and you're going to need the try-catch block. And then just stop there. So just get the beginning, the framework done, and then pause the video, do that, and then come back and we'll start coding this new example. Okay, here's what I have. So I've created my file object to the inventory file. If the file exists, I do my try catch, and in my try block, I create my scanner to the file, and I remembered to close and assign a null to my file object or my scanner stream object, which is great. That's what you should have done. And so what I want to do now is I'm going to do something similar in that I want to read each record in the file. And then this time I'm going to actually convert the integer to an integer and the double to a double and then calculate with them. So I'm going to do the same kind of while loop. So while file in dot has next line, like that. Oh, there we go. I'm going to read in my record. So string record equals file in dot next line. So if I have a record to read, then let's do that. Let's read the record. And I'm going to parse out the individual fields just like before. You're going to see that some of the times you're going to do pretty much the same set of tasks over and over, but isn't that just like programming? So my pipe delimiter. And now what I'm going to do is I want to take the second field. So you know that when you do string fields equals record.split, you know that element 0 is going to be the ID, element 1 is going to be the quantity, and element 2 is going to be the price. I often actually will jot these down on a piece of paper, but here you can do it in comments just so that I remember what I'm doing when I'm working through the code. So the first element in fields is already a string, so I'm just going to leave that one alone. But the second element, the one at index 1, that one needs to be converted into an integer. Now, in the file output videos, we talked about how you should only save valid data to your file, and that's true. That doesn't necessarily mean you can guarantee that all the data in your file is valid. In a database, you generally can, but in a flat file, you know, unless you wrote the program to create the file and no one else is going to touch it, then you're fine, right? Because you know you didn't put any invalid data in there. But because you know that you wrote good enough code that no one's going to be able to save invalid data in that file. But in a lot of situations, you just don't know. They could have hired some idiot that doesn't know what they're doing to modify your code, and then they might have allowed invalid data into the data file. So it's generally best practice to still validate the data when it comes out. So, and you'll learn that, if you haven't learned it already, you're going to learn that when you do server-side applications in JavaScript and PHP. You validate on both sides. You validate on the client side and you validate on the server side. It's just generally a good idea. It also makes your code more modular. So you could take out one of those sides of the code and use it in another application, and you wouldn't have to add any validation because it's already there. So what I'm going to do is I'm just going to use basic regex because it's easier. So first, I'm just going to create a quantity variable and a price variable. I'm not going to get too much into the error handling except for checking. I'm just going to assume if the data is not valid for one or both of these, they're going to stay at a 0, and it's just going to result in a 0 output, and that's okay. In other situations, you might want to display an error message of some kind. I'm not going to get into that here. So if the first, or fields 1, which is actually the second field, dot matches, and I'm going to use the anchors. I don't always remember to do that, but I will today. So if there's at least one digit and nothing else inside that string, then it's valid. So I'm going to go ahead and take my quantity and parse. Parse int fields 1. Fields 1, it's an array. You're not calling a method. It's okay to say fields 1 and fields 1. I've seen a few people like taking an array element and storing it in a variable and then working with the variable. That's actually taking up extra variable space you don't need to. Arrays are just like variables, so you don't have to put them in a variable. They're already a variable. That I just found that so confusing when I saw that for the first time. So yeah, you can just say fields 1, fields 1, fields 1. It's totally okay. And then for the price, I'm going to do pretty much the same thing. So only with fields 2, the third field. So if fields 2 matches, and I'm going to do, again, put my anchors in there. So there may be one or more digits. There may or may not be a decimal point. But if there is a decimal point, there's definitely going to be one or more digits, and that's all. And then price equals double dot parse double. and fields 2. There. I didn't do an else if because I just want to say I'm going to grab the quantity and parse it if I can, and then I'm going to grab the price and parse it if I can. So I'm not displaying any error messages. They'll just go in as 0 if they're not valid, and for this little demo, that's fine. I'm going to calculate, I guess I'll just call it revenue, and that's the quantity times the price. Again, if quantity and or price was invalid, then I'm multiplying something by 0, and that's okay. And then I'm going to do a nice little output. So I went ahead of time and tried to figure out what I wanted to show. So the product ID, I'll just do it really quickly here. The product ID is going to be, I think it was 7 spaces, A, B, C. Can't remember what I did. 1, 2, 3. So 3 characters, a dash, and then 4 digits. That's 8. So I'm going to have to do 8. And then a space, and then I'm going to have the price, and it'll be like, let me think. I don't know what my largest price will be, so let's say it'll be something like xxxx.xx, like that. So that's 1, 2, 3, 4, 5, 6, 7. So 7.2. So that's going to be my format. So I'm going to do % minus 8s, a space, and then, oops, $% 7.2f, and then a new line. And that should be a printf. And then I'll do my fields 0, because that's my ID. And then my, what did I call it? Revenue. There we go. I don't need this anymore. There. So, create my file object. If the file object exists, I'm going to use that file object to create an input stream using a scanner while I have records to read a record, parse out the individual fields, and then convert fields 1 and 2, or the second and third fields, to int and double, use those to calculate with, and then display the result along with the ID. And there we go. There's all 4 of my records. All nice and lined up. This is how the $ will appear in a column. That's actually quite common on reports. You'll see the $ all lined up. That's just the way numbers look professionally in reports. It's harder to read if you stick the $ right up against the first digit, so it kind of works out. That's kind of how we like to see it. If you wanted to, you could do a total. If you wanted to find the total, you could just, inside your loop, add up the revenue. So you could just say like total revenue plus equals revenue, and then add an extra print line at the bottom to print it out. It would be really easy to do. So there you go. So that's how, at least the basics of how you use a scanner to read data in from a data file. So that's it for this lesson of this week. There is one more video in this series, and that's just a summary of how to put all this stuff together into a very simple file application. So that'll be the next video, and I'll release that in time for the next lesson. So I'll see you over there. Thanks for watching.